This is Steve Smith, Director of the VLab, along with John Chattel, our Technical Production Manager of the VLabForum, coming to you live from the VLabForum studios in downtown Silver Spring, Maryland, in the shadow of the giant acorn. Today, we are pleased and privileged to have Joshua Scheck and Rich Grumm, who are going to give us a talk about the improving IDSS, Integrated Decision Support Services, and enhancing forecaster situational awareness of extreme rainfall events. Per usual, our format is about 30 minutes or so of content from Joshua first, followed up by Rich, and then a Q&A after that of about 30 minutes or so. So please ask you hold your questions until the Q&A unless it's some really important clarification thing. When we do get to the Q&A, please use the raise your hand feature of the GoToMeeting to ask a question, which we will unmute you and you can ask the question directly to Joshua or Rich, or you can use the chat feature to type in a question, in which case John Chattel will read it to us. Either way is fine. Also a reminder that the session is being recorded and will be uploaded to the VLabForum website shortly after the conclusion of this talk. So without further ado, Joshua, are you there?
Yes, Steve, thank you. Can you hear me?
We can hear you. Go right ahead.
Outstanding. Thanks for that introduction. All right. Our team is deserving of introduction, and we're managed by WPC, Dr. David Novak, and Daniel Needfeld is our team lead. Rich Grumm and I will be presenting. Stan Cizik and Trevor Alcott, John Zeitler, and my apologies to Mark Klein because he was left off the read ahead slides, and that was completely unintentional. The project was put together based on a need identified by several previous service assessments that had to do with flash flooding. It was a field-driven experiment designed by STI and the SSD chiefs, and funded by STI to demonstrate a new model for how SUE teams can work together on projects of regional or national importance and really drill down to what we can do for the Weather Service in terms of R2O. So the goal of this project was to validate and deliver a situational awareness tool. That's as simple as we can state it. The tool needed to be focused on flash flooding, and it needed to be not created in a stovepipe, but consider all of the other projects going on around it and move forward, helping forecasters deliver better IDSS in an area that was identified with a need. The anticipated results, of course, is then to provide improved IDSS, and I think it's worth stressing the focus was on these top 1% or extreme rainfall events, not every flash flood that verifies in storm data. So we're trying to hit these huge, life-changing, high-impact events and give forecasters a tool that screams, hey, look at me, and forecasters can then begin their messaging and their IDSS process. So the team was formed and reviewed research, the state of service assessments and current state of the science, and we were all brought together, or most of us were able to make it to Boulder. We met with brilliant people, Kelly Mahoney, Dave Gochis. I don't want to, I'll screw up the pronunciations of names, but these very brilliant people are working on outstanding things, and they're really trying to meet the needs of the field. We wanted to make sure that this project was aligned with all of these great movements forward without duplicating effort, but at the same time get something in the offices with a more agile approach, so that offices can better integrate with NCEP and with the messaging that's outside of their office. Key considerations. After meeting with all these folks, the team had, just mountains of information to assimilate. But there were issues. Should we stick with R climate, or should we be considering M climate? Do we use raw QPF in short term? Because there is no good M climate for high-res models, and I hope someone contradicts me at the end of this talk in the comments portion, because we want to know about those kind of innovations. And I heard that there may be some HRRR model climate development discussions. You know, comparing that with a post-process QPF and our climate, do we use exceedances? How do we want to do this? Should it be web-based or AWIPS2? AWIPS2 is our display program, the display system of choice. We've invested a lot of money in it. Should we really be depending on web-based systems? How experimental are the data sets? Can we rely on them to deliver an operational product or an operational tool within 2 years? Or should we just be aware of them and then design a tool with an architecture that will allow for new data sets to be ingested into that tool, or to adjust the tool with future versions to allow the tool to grow? The NOAA Atlas 14 limitations, Texas, the Northwest, even the Northeast, which is being developed, those areas are lacking. They do not have NOAA 14 data sets. Russ Schumacher ended up finding solutions for that and loaning us his data set, his grid, and we were able to pull it in. So, I mean, big considerations and limitations with how that data set gets formed, whether we can do 1 hour or 3 hour or 6 hour exceedances. And then looking at OCONUS and NCEP and the RFCs, they need to be included. There is an issue with GFE and the NCEP perspective, and I believe Alaska is doing some things with an interactive tool that allows them to work with the grids using a GFE-like application without ramming into GFE and hacking it apart. They've found some innovations. What other innovations are out there? How can we leverage that? How involved should GSD be in the development? Can we contract GSD? Do they have the time? Do they have the people? Should a tool be centrally processed? We really, really, really want centrally processed. We need to move there. It's been identified that people a lot smarter and higher up than all of us on the team have identified it and heard the message, and I believe that we're moving there. But is that something we should tackle now with this project, or should we hold off, allow that to be another project, and not have that slow us down? That it's a critical question that needed to be answered by the team, and along with what platforms and perspectives should display. If we're going to deliver a field tool, but NCEP has to message, and they're tweeting and they're Facebooking and they're serving ROCs and NOCs and national media and national partners, shouldn't they have access to the same tool, that we be collaborating with a fully integrated structure, consistency? These are issues that the team all considered. Which framework? Can we build a tool in GFE and count on NCEP to be able to view it and use it? Or should we stick with web-based, because a lot of times that's easier than navigating the difficulties? So a simplistic view of this issue: how much rain will fall? Is that a lot? And will it flood? That's really what we're looking at. And my hat's off to Trevor Alcott, because I can't tell you how many times he's said that, and Rich Grumm too. It's really getting down to the problem. How much QPF is there in the forecast? Is that climatologically significant? You can have a 100-year event that barely has runoff, and then you can have a 50-year event that floods everything. The hydrologic response is reached through the QPF and how significant that is, considering two factors: the return interval and coverage of the significant rainfall, and the antecedent conditions. And there are projects dealing with the antecedent conditions. There's flash, there's wharf hydro, there are test bed projects looking at that, HMT projects. We want to stay in our lane. Remember, we don't want to duplicate efforts. There's refereed research that does validate that the significance of rainfall is very strongly correlated to the occurrence of flooding, the occurrence of flash flooding. So we're going to stick in our lane, and we're going to focus on that return interval and coverage. Here is a mock-up of the situational awareness dashboard that we came up with. And it obviously goes out beyond day 3, and the numbers, don't get too excited, the numbers are just fabricated, they're thrown in because it's a concept. We're talking about using data sets like the HER time lag in the very near term, moving into the SSEO with the high-res NMM and WRF, ARWs, going into a SHREF MME concept beyond that SSEO time frame, and then eventually into the GEFs and the national blend of models. And it's important to note that there needs to be a transition in the shorter terms where we're validating, we're comparing the ensemble, the probabilistic information on a convective allowing model structure, and we're transitioning that, so we're comparing raw QPF to a model output or model output QPF directly to exceedances versus further out in time. We're looking at using M climate. We're moving away from the R climate until we start dealing with things like the national blender, which are already bias corrected. The colors would be calibrated to the percentage of members that reach certain thresholds. That needs to be calibrated. We need to match those colors to the HAZSIMP group. We want to be consistent. We want people looking at the same color scheme and getting used to that. And we apologize in advance to those that have more difficulty with color. We have to figure out ways around that. But the main focus is make all of that consistent. The values in the boxes are the fractional percentages. We want to display the percentage of 100-year interval precip reached by the highest QPF data point in that domain. And that's including all members. So the colors can contradict the fractional percentages sometimes. We could calibrate, we could say if 50% of the members reach half of the 100-year interval. And we find that that's the most useful through testing and validation. Maybe we don't need to be at 100-year, although the research suggests 100-year exceedance is where we want to be for flash flooding, and we like that. I'm just throwing that out there conceptually to let you know that we're not hard-pressed, we're not set on any of that. It's purely a mock-up. So the phases of the project. We're starting out with a prototype. We got to move the HER time lag, get some SSEO, GEFs, national blend of models, and official. We need to align with HAZSIMP and use that 100-year recurrence interval. And I already said Russ Schumacher already provided us with the data that we need to do that. Phase 2, the initial operating capability. We want to make the software available, but we still have to calibrate those colors. We want to engage the test beds, the OPG. We got to prototype the NCEP solution, so we're allowing for more time for that, but we really need NCEP on board with this, and we need to start looking at OCONUS. I think people forget that even though Alaska is north, that they flash flood too, and we have to consider them and all of our other OCONUS areas. Phase 3, we're looking at full implementation. We need case studies. We have to formalize training. We need to calibrate those color table thresholds so that we're intuitively alerting forecasters, hey, this is a case you need to start paying attention to, start crafting that message, and that could be used to initiate WPC collaboration. Let's make sure we're all on board. We need to verify and validate, and we need a full NCEP solution by phase 3. I wanted to show, well, we all agreed to show the phase 4, the wish list items. We want to integrate WRF Hydro. We've considered all of these other projects, the PQPF calibration, the different M climates, FFMP integration, the concept of basin-based alerting. We want to do all that along with centralized post-processing, but we realize that we have to do what we can in the 2 years that this is scheduled to be ongoing. So we've identified work for contractors, and I don't want to read all this off because I think people might have questions and be curious about what the contractor's doing, but Rich's work is much more important to present in the interest of time. And with that, we want to tell you that the team hasn't stopped. We're not dropping this. We got to be training on using that SA tool in GFE. We got to be working with researchers and stay in the loop on new projects. We have to develop all this training on using the tool, training on using NOAA. We need case studies across the Weather Service, and we need to show how this tool can work for everyone in the field. We don't want this to be another great tool that gets advertised and doesn't take off just because people weren't really sure how it would work. We want true validation. We want this project to be a benefit to the field. And Ming Ji and STI and David Novak have been very clear that Sue's working together. We can make a difference in this way. So with that, I'd like to turn it over to Rich Grumm, and John's going to switch panelists. Thank you all, and I'll stay on, of course.
Everybody see my screen?
I see you, Rich.
Thanks.
Yeah, we can see it, Rich.
So this is more kind of a practical of examples and some stuff we've learned over the last 4 to 5 years, and really since the Western Region Situational Awareness Table came into use, especially with the M-Climate QPF. And the bottom line, and Josh said this earlier on with conversations with Trevor over the last couple of years, and I'm working on this project to kind of reinforce it, that some of this stuff requires a paradigm shift in forecasting. And then we'll talk initially about, M-Climate, or the internal model-based climate, which is really an important forecast tool. It doesn't have all the biases when you compare the QPF versus, say, what really happens inside the model's atmosphere. So the models can produce the known patterns, and most of us feel comfortable talking about, the plume of moisture, the atmospheric river, all these terms. We're really good at recognizing these signals, whether it's from climate data or forecasts. And the models they do produce these signals, especially with synoptically forced systems. They produce them well. But the thing that the model knows is the model knows where it has the lift, where that frontal boundary is, or that mountain is causing the lift. It knows in the model system where this lift's going to occur. And if you have an ensemble forecast system, it knows where each member has and produces its QPF based on that lift. So it may have the pattern of the QPF correct, or it may have the QPF in the wrong place. So the ensemble, of course, would provide a probability. This is why the M-Climate seems to show a lot of potential and has shown in the few years that it's been implemented to help identify high-impact weather events. So we'll look at a few that have been cataloged, and you can go to this, if you have an event in your area, you can go to the Western Region Situational Awareness table and use the archive tool to examine some. So we'll just show a few events. We won't show all of them. There were some really good events in December. We showed a low-end one, but we're going to show more. We're putting together a poster for the Sioux workshop and at the NWA meeting. This was an event in Southern California in early December. This is the from the NMQ flash site. And the MRMS data has ARIs in it too, so there'll be eventually be a seamless transition between using observational data to forecast flash floods and forecast data. But you can see the heavy rain was in Southern California, Central California, and this was the M climate from the situational awareness table. You can see it was kind of hinting of some potential heavy rainfall, at least along or off the coast of Northern California. And as the forecast came in and started to hone in on the area, this was a plausible example. We have better ones, but we don't always want to show the best ones all the time. And so the bottom line was the models had a signal, at least in the M climate, that could be some potential heavy rain in California. And then, as everybody knows, we've had some really good heavy rain events in the southern plains this spring and early summer. And so we'll look at an event, the NMQ data actually had 10 inches of rain in places in Texas, and there was also a Louisiana event that occurred. But here's the heavy rainfall that occurred in Texas. And then this was the signal from the M climate. So if you go back, you'll see it knew there was going to be heavy rain in the general area of the Texas Panhandle. It didn't know really where, but there was clearly a synoptic signal and what really proved to be a quasi-mesoscale, of course, intense rainfall event. And as the short forecast length got shorter, it actually was showing that the GEFS was trying to forecast an all-time record amount for that period in the Panhandle of Texas. Again, it wasn't in the exact spot, but it had a coherent signal that somewhere in Texas, Oklahoma Panhandle, the potential existed in the model atmosphere for what could be a record rainfall event, which then should cue or alert the forecaster that somewhere in this domain there could be heavy rain. Of course, there's going to be uncertainty in the exact location. And this is just another event from the 19th, and you can see there's pretty heavy rain in Louisiana. There's actually some rain back in Texas. And then the M climate, and this is the GEFS, which is a pretty coarse forecast system, doesn't have any real convection. It uses a convective parameterization scheme. Of course, it's a hydrostatic model, but it actually had a signal in Louisiana pretty close to where the heavy rain occurred, because clearly there was a good synoptic signal, so it missed the real extreme rainfall event, but it had the pattern right to show there could be at least a 99 percentile rainfall event based on the model internal climatology. And then May 24th was another extreme event. It was in Texas, Oklahoma, and again the GEFS-M climate had a really good signal. And so you might ask yourself why. Well, if the model has the correct pattern, which we're good at pattern recognition, and the model has some knowledge of the instability of the moisture, it'll know where it wants it to lift. And if you have an ensemble of models, it might focus on the right general area. So this is the rainfall that was observed. You can see there was heavy rain both in Texas and Oklahoma. And there were two areas of heavy rain. And you can see that the GEFS-M climate was forecasting in the 18 to 30-hour period two extreme rainfall event potentials, one in Texas and one in Oklahoma. Now, if you look at the details, there's a lot of, it wasn't perfect, but it got the signal that there was a synoptic pattern that favored heavy rain somewhere in Oklahoma and somewhere in Texas, and it turned to be a viable signal to help alert the forecaster. This is just another forecast in the 24 to 30-hour forecast, a little shorter. And but I want to go back here. It really shows you how it really highlighted the potential for heavy rain in both Oklahoma and Texas. So another tool, and this is being used down at the NSL site, is average return or recurrence intervals, ARI. And Josh talked about the NOAA 14 and the NOAA 40 blend that we've been kind of using, and that was provided by Russ Schumacher. But you can get these return intervals, and there's a lot of different return intervals, and they all have a lot of applications. And for a national scale type alert system, we kind of agreed on initially starting with the 100-year and 24-hour, and we're also using some 6-hour data. But clearly there are other intervals that could be considered, especially for local forecast problems. But because our models and our ensemble forecast systems, which is EFSs here, can produce the QPF, then we can try to relate these back to extreme rainfall and return periods. And these data, of course, lack the antecedent conditions. So if you have a lot of rain and it's dry, you might be able to handle it. But that's a piece of the puzzle that we're not addressing here. But it could help us with flood and flood potential issues if the forecaster was, of course, mindful of the antecedent conditions. So this is just a 24-hour ARI plot across the United States from the data we have. And you can see, of course, it really requires a lot of rainfall on the Gulf Coast, about 300 millimeters or more, to get an extreme rainfall event. Whereas you see in the Intermountain West, in some places as little as 25 to 50 millimeters or 1 to 2 inches of rain is an extreme rainfall event. So you can then apply these data to model forecasts. And so this is a zoom up of an area of concern. For example, we'll show the Southern Plains, and this is the 24-hour, displayed on a GFS grid of the ARI. The 24 main rain event made the national news, so it's a good event to pick. And so on the right-hand side, we have a loop of the lower panel shows the QPF as forecast by the NCEP GFS, and then the upper panel starts out showing the ARI. Then it shows the QPF forecast through the single GFS relative to the return periods. And as time goes on, you begin to see in Oklahoma the yellows and the orange colors. We're getting between like 50 to 100% of the 100-year return period ARI, suggesting this would be a pretty potentially significant rainfall event in Oklahoma. And you can see how the angle of the band of rainfall. And then this just shows a static image of that. You can see there's some oranges in Oklahoma and mainly yellows. And this is how the alert system would work. The yellows would say we're approaching 50 to 75% of the 100-year 24-hour return rate, and the oranges in here would say we're in the 75 to 100% of the 100-year ARI. So there's some useful information there. And in the bottom panel, you can see the GFS was forecasting on the order of 4 to 5 inches of rain in that same general area. And this is another set of forecasts, and you can see just a different time period, the rainfall that it was forecasting. Again, you can see the high return intervals, the high percentage of the ARI in Oklahoma here with the high QPF. And this is just another forecast. So the point here is successive GFS forecasts were forecasting a high amount of QPF, and this QPF was in the short range forecast was getting into the 75 to 100% of the 100-year return period of a 24-hour rainfall event. So it's getting close to a pretty impressive rainfall event. So we could get these signals out of models if we have the resolution of the data. And so far we've seen some success applying this to the HERD and 6-hour return intervals, the NAM, the 12-quantum NAM and the GFS. And clearly this might be able to be applied to the SREF. There's some concern that the GEFS is too coarse, and at the range we want to use it to forecast with, we're probably better off sticking to the M climate. So in summary, the GEFS M climate can really help us identify some potentially big rainfall events, especially when we have a good synoptic signal. Most forecasters historically have done this using pattern recognition, but the GEFS, the M climate, can do this kind of with the pattern recognition kind of built into where the model knows there's moisture and lift, and the EFS members help us know relatively where the lift is going to be, and in a more statistical sense, because each member may have the lift and the resulting QPF in a slightly different place. And as the example showed here, even in what we would consider convective events in the Southern Plains, if you have a really strong synoptic signal, the GFS is capable of giving you clues for the potential for heavy rain in the right geographic domain. And the M climate and the average return intervals, they hold a lot of hope to produce, I think, effective alerting systems for us. But we really need to build a provable case library so we can demonstrate the utility and get more forecasters interested in and more learned on how to use these kinds of data. That's all I have.
Okay, Rich and Joshua, thank you very much. Very interesting talk, very good summary, and I think we got quite a few questions. So let's start, John. Again, for folks on the GoToMeeting, if you would like to ask a question directly, use the raise your hand feature, and we'll unmute you, or the chat feature. John, do we have anybody who would like to ask a question?
Not quite yet, no.
Okay, we've got one in the room, Dave Rudak.
Hello, very nice presentations. Just a question.
when you look at the M climatology, do you know how many times where it actually said, oh, there's going to be there's a really good chance, and really how many times that verified, so you don't really get kind of a false signal? In other words, most of those times through that period where it really said we're going to get a lot of rain, did it in fact? So this is something we could really lean on. I don't know who could answer that, but
Does Trevor have the verification?
yeah.
Go ahead, Trevor. We can hear you. Go ahead. Somebody was going to answer.
Is Trevor on the line? Does he did the verification and he knows?
Oh, is Trevor on the line?
Okay, hold on a second. I'm looking.
We're checking. Hold on.
What's let's see.
Trevor Alcott. Trevor Alcott.
Okay. I don't see his name here.
Doesn't look like Trevor's on the line, guys.
Hey, Dave, we can find that information. This is Joshua. We can find out that
Okay.
information and send it to you. It's a great question.
Okay, thank you. I mean,
And
yeah. No rush.
but it has been done and considered, so that you know.
Okay, that would make sense that it would be.
Bob?
A comment and a question, I guess. I was a little surprised that you went with a 100-year, more maybe a 50-year or something like that. Seems like you're aiming for a small number. But anyway, the verification interests me. I think when you develop something like this, it can be a good tool for warning and stuff like that. But when you get to actual verification, that makes it pretty interesting, especially if you're trying to replace or get something better that's already in existence. Many times there are objective tools that are defined, and you have no idea whether it's any better than what has already been implemented because it's not verified that way. So is there any sort of baseline you have to shoot against for this when you do verification? My guess is not.
Joshua?
No, all the verification has been done internally versus the GEFS and the M climate. And we know the bias is, of course, in the GEFS internal model QPF climate. But we don't have there's no comparison standard.
Any comment on Bob's question about the 50 versus 100-year return period?
Well, I can comment
Bob.
on that. We've done about 50 different case studies, and we found one paper on flooding, and we kind of found that you start in the normal, most of the events that we've looked at, when you get about a 10-year return interval precipitation event, you usually get like just what we call puddle alerts, like advisory category issues. Usually 50 years, you kind of mostly advisory. Sometimes you're getting into issues with, flash flooding. It seems like when you get to about 100, to especially 500-year return periods, you're getting into serious flooding issues. So we try to lean ourselves towards events that would cause flooding based on case studies. And we can only find one paper from St. Louis University in addition to our case studies of what interval would work. But we kind of pick a number that would be more serious flooding, high-end flooding.
I mean, don't you think, like, in terms of amount, having something a little less that happens more frequently might be more beneficial than something like that? Because I don't know how often those red lights or buttons are going to go on, just in terms of normal utility in the weather forecast office. You know what I'm saying? Just
understood.
Yeah, maybe I can address that. This is Joshua.
Okay.
You bring up a good point, and we did discuss that. I don't know if we could go back to the mock-up, but that's one of the reasons we discussed having the boxes be colored when there was no member, when the criteria wasn't being met, even before the 100-year. Here, I have. There we go. I can go back on the screen.
That's why we express the percentages.
Exactly. exactly. That's what the point was for expressing the fractional percentages. So looking at this image, hopefully you can see my screen.
We can.
Yes.
In concept, you'll notice that the yellows are highlighting, even though the most aggressive ensemble member in the bottom right of day 3 is listed as 66. So that's 66% of the 100-year interval is being met during that 24-hour period, or during a 6-hour period within that 24 hours, depending on how the tool gets developed and validated. So we have allowed for that issue because we don't want forecasters to never look at it because it always shows green until they need a boat to get home from work. But at the same time, we don't want this thing yellow all the time, all summer. We don't want to overestimate the risk of flash flooding, especially for I hope several people hate the term garden variety, but I'm going to use it. Garden variety thunderstorm flash puddling. We don't want alerts drawn for that, and we expect IDSS for those scenarios is already being done. We're already sending out our emails and notifying people, and we have the slight risk excessive outlook from WPC and maybe flash flood watch or advisories being issued depending on the situation. So remember, going back to our charge, we're really after these extreme events. We're after the Duluth, the flooding that we just saw in Texas and Oklahoma. We're after the Estes Park flooding, in Boulder flooding. We're after those events, and how are we going to start sounding the alarm to forecasters further out in the time period to let them know it's time to start messaging and paying attention?
There's another point here too. Like, I don't know how many people on the line may have been to the hazardous weather test bed where they were looking at rainfall thresholds, and I guess they used 2 and 100, so they gave the very low end and then they give the very high end. So there's different ways to do this, and the data exists for like 1 hour, 3 hours, 6 hours. You can do this over different hourly increments, and you can do it over different ARIs too, and thresholds. But I think in HWT they were using 2 for just the low end to alert you that there's some potential, and then they went to 100 years. They kind of bracketed it at the extreme light side and more heavy side.
We've got a couple questions online, so John.
Sure. Jeff Waldstreicher has a question. He's been unmuted.
Go ahead, Jeff.
Hi, this is actually Brian Maretsky from Eastern Region SSD. I wasn't quite clear from the presentation as to what phase you're in or where you're exactly holding in the project. You've got a mock-up here. Do you already feel like you selected and are assigning a contractor to some work, or are you still doing testing?
Hey, Brian. Sorry, Rich. Maybe, John, you could unmute Daniel Needfeld. I think he's in a good place to comment on that. We talked before the presentation.
I don't see him online, actually.
Is he under another person's name?
He would be maybe David Novak and maybe Mark Klein. Those are the 2 I think he's probably sitting with at WPC right now.
No.
And if those aren't on, then I can say that maybe I can address it. Oh, he's texting me now.
Okay. Ben Albright? Okay.
Ben Albright. Thank you.
All right, we got it.
He hasn't entered his, audio ID, so I can't unmute him. Dan Albright needs to enter his ID, and I can send it.
If it's okay, let's table that, and we'll follow up with the whole group. Let me text him really quick if there's another question.
Yeah, he said he accidentally hung up, so.
Okay.
All right. While
Do we want to go to Pat Spoden?
go to Pat Spoden, yeah.
Okay, so I've unmuted Pat. Go ahead, Pat.
Go ahead, Pat.
Okay, great presentation. I really love the ensemble situational awareness table now that Trevor has trimmed it down to my area. One of the things I want to talk to Rich about is, you know, you're showing some nice graphics about 100-year rainfall amounts, and instead of waiting for this tool to potentially show up someday, is that kind of data actually available somewhere on the web?
Absolutely. Well, we prototyped it in April and we put it on the web in May.
Okay.
So I have it up on my website. When we look at the GFS and the HER QPF, we have 24-hour 100 for the GFS, and we have 6-year 100 for the HER. And we're probably going to release 100-year return period 100 for the NAM12.
Okay, can you send out the a link to that?
I guess I could.
I would appreciate it instead of searching.
Experimental fun.
Yeah, I'd love to look at it.
Thank you.
Did we get?
They were back online, but now they've left again for some reason.
Okay, question. Dennis Miller's got a question. Go ahead, Dennis.
Yeah, in this mock-up, why is it that, like in day 3, for example, the colors, like for the GEFS model, 192 is in red, but then for a couple of other models in purple, you have lower and higher values. How is that determined?
That's a very good observation, and it's a good question, and it's actually not a mistake. When the team discussed it, what we talked about was the idea that the colors would be tied to the percentage of ensemble members that were in exceedance of a certain calibrated level based on the 100-year return interval. But those fractional percentages, if you remember, are based on the highest QPF of any one of those ensemble members. So if you think of the distribution, you could have, just say an ensemble of 10, you could have 9 of those members all be in the below a 50% of the 100-year flood, and one member has got 27 inches. That would bump up your fractional percentage, but certainly you'd be in the green. Do you see what I mean? So the fractional percent is the percent of that 100-year threshold, not of the number of members that have exceeded it.
The fraction that met the 100-year threshold, or came within like 75% of it, or what?
Yeah, well, okay, the fraction is the percent of that 100 years. So if your 100-year threshold is 2 inches, and the fractional percent number that's displayed is 50, then the most aggressive QPF came out with a 1-inch QPF, and every other member was less than that. So the two represent something a little different, and it's just a concept, and it really needs to be tested, validated, and that sort of thing. But we thought that information could be valuable.
If I were to provide a little perspective, I would personally say I would find this a little more confusing than maybe having one table with the max amount of any of the members and another table with the percentage of the members, or some approach like that.
Yeah, I mean, similar things we've dealt with in FFmpeg, where you can put like worst case scenario displays versus base and average kind of thing. I mean, it's really sometimes a question of the event itself. So it's probably not a silver bullet for this. I want to get back to this question about what the problem is where you guys are trying to address. So is it that there's a heavy rain event captured in the ensemble, is captured by the model, individual members. The forecasters are aware of it, but they don't know that it's going to be a 100-year event. Is that the problem we're trying to address, or is it that we want to identify this much earlier in time, or is it both of those things? Rich or Joshua, doesn't matter to me.
This is Joshua. Maybe Rich has comments, and I think Daniel's going to chat you because I think they fixed their problem connecting. The problem is both. We look at service assessments and we see that signals have existed, but we're not adequately milking the probabilistic envelope and identifying confidence with those events. And we need some validation. We need a tool that is easy to use. So I wrote down your feedback about the numbers, and that certainly will be considered. The issue is that forecasters don't know what to trust. We've seen cases, and maybe this is better for Rich to comment on, but we've seen cases and discussed them where there were signals, but do we believe in ensemble? How do you know that when the GEFS, for instance, has 2.5 inches, the GEFS members are forecasting 2.5, that you're going to get 13? Is that significant, and have we done our best to get that information out of the ensemble? And that's where Trevor's work can be extrapolated into this, and Rich's case studies can help validate it. So hopefully that gets Rich started, and Daniel if he has more.
I think you answered it correctly. I think our original charter said our main goal was to ferret out that top 1% extreme rainfall events, hence the name of the team. And then, of course, along the way, when we started looking at examples, in case we found out that it would help us identify a wider range. But our real goal was to get these super extreme events, the 1%.
Yeah, this is Daniel myself. Thanks for your patience. Yeah, we did. We're identified to or to help identify those top 1%. But one thing we haven't really set anything in stone. I mean, clearly this is just in mock-up format now, and so a lot of decisions still have to be made. And I think part of the process is to go through the cases, a lot of those that Rich has collected, and run some of these numbers and try to determine what the methodology would be that makes the most sense, that sort of communicates to the forecasters that this is an event worth keeping an eye on.
Okay, very good. Go ahead, Bob.
You answered my question very well, I think, about the 100-year. You're really using that as a kind of a calibration thing. I mean, when you get down to having your color table here and so on, where you've only got percentages and stuff like that, you're really addressing more than the 100-year, in a sense. I mean, you might come down and say, well, if you got a certain color up there, that's 50 or something. Anyway, that sounded a lot better. One of the things that does concern me, though, and especially with these extremely rare events, when you're talking about probabilities, whatever you manage to come up with in probabilities, which is going to take a sample of some sort, and you're talking about calibrating a model, especially for large amounts, that calibration might go to pot when the model changes.
Absolutely.
So I think, trying to squeeze down to exact numbers and so on is probably not going to happen.
Any response to Bob's comment?
Well, immediately, one important response is part of the NCEP model suite in the evolution of GEFS specifically is to continue to do and make reforecasting an important initiative. So whenever there is a model change, at least, we have a new M-climate we can build. And the other issue about that is NCEP is working hard, and there's some work, I guess, at GSD to help us get calibrated QPS, which is something we're really weak on in using and having access to in field offices. That's a partial answer to Bob's question.
Okay.
Go ahead.
Can we follow up now that Dan's on the call?
Yeah, right. Which phase are you in? Yeah, Dan, you want to answer that?
Which phase and sorry, Dan, and kind of have you already selected a tool, or are you still really in the mock-up phase?
Well, I think that, first of all, regarding the contractor, we've gone through the process of identifying the contractor and hope to have that person starting on the work in October, so fairly soon. And right now, the plan is to go forward with a GFE type of a smart tool, which would which would do the displaying, at least again initially, something that all of the WFOs certainly have. So that part of it, as far as the contractor goes, we're making some progress on.
Okay. We had a question from Ken here in Eastern Region related to that.
Dan, I don't know if it's you or Josh that can answer this, but you raised the issue of the work GSD is doing in terms of situational awareness display and so forth. Are you able to leverage any of the work that GSD is doing in this project, or has it been determined that you're going to have to, come up with your own stuff?
Yeah, I can take a stab at that. Actually, some of the framework was originally designed by Tom Lefebvre at GSD, and so to some extent, we're working off of some of his original ideas. And then the contractor, we expect that person to be able to work really closely with GSD and certainly leverage the resources there. So that's the plan.
Okay, thanks.
Let's see, either Dan or Joshua or Rich. So you talked about your lane for this overall thing is the significant rainfall. So is there another team with DOEs and other hydro folks working on the antecedent conditions part of this?
This is Daniel. I can try that too. You guys can chime in. There's just quite a bit of work going on with WRF Hydro. There's a few USWRP projects that are underway. And we did, as Joshua mentioned, when we met in Boulder, we met with the group that is doing some good work on that. So, and then of course there's the group at NSSL with J.J. Gorley working on Flash, which isn't exactly the same, but it's quite similar. And so we're trying to leverage what's out there with that, let them move forward and do their work. And this is a little bit more of a very practical, operationally based tool that we can probably put into operations, as soon as the tool is been developed and ready. I'll leave it at that.
Okay, good enough. We have any other questions online, Sean?
Yeah, we have a couple. Daniel Melendez would like to ask a question, and I've unmuted him.
Daniel, you want to answer your question?
I want to ask you, I don't know if I can answer it. Thanks. So are there verification or statistics about the performance of the members somewhere? It would seem to me that there may be other ways of looking at the performance of those members and models that were used. Is there a place to go for that?
I can take a shot. This is Daniel again, and I think about the best I can give you is that Trevor Elcott, when he did some work with the M-Climate, and we're pretty sure that he did some verification. I think that was mostly cool season verification, and I don't know that he's published that or not, but as Josh mentioned, we can dig a little bit deeper on that and try to find out and get back to you.
At one point, there's no verifications I'm aware of by ensemble member. This was kind of a mean QPF from the GEFS forecast system. There's no individual members in this.
Okay, thank you. John?
Sure. Woody Roberts would like to ask a question.
Woody, go ahead.
Hi, this is more of a comment just about the GSD involvement. We have been developing tools, including the forecast monitor and short-term update, that are very specific to situational awareness. And the expectation is that we would have a row, so to speak, in this table in the future that would have kind of a first order alert to the forecasters that there is a significant event coming up, so they can compare it with their current forecast, and also have a way of linking to some of these more sophisticated tools like you're talking about, so they can go in more depth to look at it. Presuming it's all on AWIPS, and that's of course the platform we're working on. So if the data's there, we want to be able to link up these tools together so forecasters aren't bouncing around too much between tools.
Thanks, Woody. We're running up to the top of the hour here, but I got to ask a kind of philosophical question, since I've been in this business of tools and monitors and so forth for quite a while. And so, back in the day, there was WDSS cell table, and we moved that into SCAN and FFmpeg and et cetera. So there's lots of tables with colors on them, and you see a proliferation of these things. So does people feel like that's really the best way to extract the information you're looking for in terms of providing the situational awareness, or is that just sort of the default thing that we know to go to? Anybody can chime in on that question.
That's a great question, Steve. This is Daniel. I don't think I have an answer, but one thing that we did talk about that I think that we want to incorporate with this is that the forecaster could click on one of those colored boxes and then hopefully get the map that shows some of the components that made the color what it was. So maybe a little bit more than just a colored table, ideally.
I mean, Rich, come on, you've been forecasting for how many years, how many decades? I mean, do you need a table to tell you, what to pay attention to?
Me? 35 years. Well, like I said, most of us do a lot of pattern recognition, but I think philosophically, I'm going to be careful to answer this. I think with people who have kept, their skill set high, they probably can recognize and use the right guidance, if you will, to facilitate understanding where there might be a threat for heavy precipitation or extreme rainfall event. But we all have varying degrees of skill and ability, so I think it's sort of like how numeric weather prediction has had made the average guy on the web who doesn't know how to forecast the weather a relatively good forecaster in social media space. I think a tool like this has the ability to level the playing field between forecasters with disparate abilities and skills.
Very well put.
One other quick point is, again, the motivation for this is that when we have these extremely high-end events, they're really, we tend to not do great with them. So we have room to improve for sure.
Got it. Well, this has been a very stimulating discussion, and thanks very much, Joshua and Rich and Dan, for the update. Really good stuff coming out of this field-led project. Lots of important people involved, so wish you all the best of luck, and probably, maybe in a year we'll come back and see how things are going. How about that?
Thank you. You're very kind.
All right.
And we would certainly love that.
All right. Very good. So thanks, everyone, and as a reminder, we'll upload the recording of this up to the web page shortly after this, so you can share it with your friends who weren't able to make the session. So thanks, everyone, and we'll see you again next month.